the intersection of luxury tourism and infectious disease surveillance has reached a critical juncture following reports of a potential hantavirus outbreak linked to a cruise vessel's internal infrastructure. According to current reporting, the investigation focuses on the ship's ventilation systems as the primary vector for pathogen dispersal, a development that challenges standard assumptions about hantavirus transmission, which is typically associated with rural or wilderness settings. For travellers and public health officials, this incident highlights a concerning vulnerability in closed-circuit environmental controls. While a cruise ship is often viewed as a controlled environment, it remains susceptible to the ingress of local fauna, particularly when docked in regions where rodent populations serve as natural reservoirs for the virus. To understand why this report is generating significant concern among epidemiologists, one must first look at the unique nature of hantaviruses. Unlike many common respiratory viruses, hantaviruses are zoonotic, meaning they jump from animals to humans. Specifically, they are carried by various species of rodents, including deer mice, cotton rats, and rice rats. The virus is shed through the animal's urine, droppings, and saliva. In a standard terrestrial scenario, a person might become infected by breathing in contaminated dust after a nest is disturbed in a cabin or shed. However, the report of a biotrap scenario on a holiday cruise suggests a much more efficient and dangerous distribution mechanism. If a rodent infestation reaches the internal ductwork of a large vessel, the very systems designed to provide climate control and fresh air can inadvertently become a delivery system for viral aerosols. This transformation of life support infrastructure into a transmission network represents a significant logistical and medical nightmare for maritime operators. The framing of this incident as hell on holiday underscores the psychological and physical impact on passengers who find themselves trapped in a localized epidemic. For the broader public, it serves as a reminder that the barriers between human habitats and wild viral reservoirs are thinner than they appear. As we examine the specifics of this case, it is essential to remain focused on the verified mechanisms of spread. Hantavirus pulmonary syndrome, or HPS, and hemorrhagic fever with Renal syndrome, or HFRS, are the two primary clinical manifestations worldwide. While the specific strain in this cruise incident requires further laboratory confirmation, the presence of the virus in a high-density, multi-deck environment necessitates an immediate and robust response from international health agencies and maritime authorities. The gravity of the situation lies in the fact that cruise ships are essentially floating cities, where thousands of people share the same air supply, making the containment of an aerosolized pathogen exceptionally difficult once the ventilation system has been compromised. This lead investigation will track the trajectory of the reporting, the biological risks involved, and the immediate steps taken to secure the safety of those on board. The core developments of this investigation centre on the technical assessment of the vessel's ventilation and the subsequent diagnostic challenges faced by medical teams. When an outbreak is suspected on a cruise ship, the first line of defence is the shipboard medical centre. But hantavirus presents a unique set of hurdles. The incubation period can range from 1 to 8 weeks, meaning many passengers may not show symptoms until long after they have disembarked and returned to their home countries. This creates a massive challenge for contact tracing and global surveillance. According to the source, the focus is squarely on how the virus seeped through the ventilation systems. This indicates a potential breach in the integrity of the ship's rodent proofing or a failure in the maintenance of high-efficiency particulate air filters, commonly known as HEPA filters. In a modern cruise liner, air is typically recirculated and filtered. If these filters are bypassed, or if a rodent nest is located downstream of the filtration unit, the distribution of viral particles becomes inevitable. Laboratory and testing protocols for hantavirus are rigorous. Initial screening usually involves checking for specific antibodies, such as IgM and IgG, which the body produces in response to the infection. However, in the early stages, these may not be detectable, leading to potential false negatives. More definitive testing involves reverse transcription polymerase chain reaction, or RT-PCR, which looks for the actual genetic material of the virus in blood or tissue samples. For the agencies involved, such as the relevant National Centres for Disease Control and Maritime health regulators, the priority is identifying the specific rodent reservoir involved to determine the exact strain of the virus. This is critical because some hantavirus strains have much higher mortality rates than others. There is also the question of verified information versus public alarm. While the source characterises the ship as a biotrap, health officials must balance this with the known science of the virus. Historically, hantaviruses are not known to spread through person-to-person contact, with the notable exception of the Andes virus in South America. Therefore, the risk is strictly environmental. If the ventilation system is the source, then the trap is the environment itself, rather than the presence of other passengers. The shipping and travel logistics involved in a quarantine of this scale are immense. Ships must be diverted to ports capable of handling a biological hazard, and specialised cleaning crews using bleach solutions or other professional-grade disinfectants must be deployed. These crews must wear full personal protective equipment, including powered air-purifying respirators, to avoid becoming the next victims of the aerosolized pathogens. The complexity of disinfecting miles of intricate ductwork cannot be overstated. As lab results trickle in, the contrast between the sensationalist claims of a dream cruise turned nightmare and the cold, methodical reality of epidemiological work becomes clear. Every surface, every filter, and every crawl space must be scrutinised to eliminate the source of the aerosolization and ensure that no further passengers are exposed to the life-threatening risks associated with hantavirus. Moving forward, the focus shifts to prevention, long-term surveillance, and the public health guidance necessary to prevent a recurrence of such an event. For the cruise industry and international travel authorities, the lesson is one of vigilance regarding integrated pest management. Standard prevention for hantavirus is relatively straightforward in theory, but difficult in the complex architecture of a massive ship. It involves sealing any gaps larger than a quarter-inch, which is the size of a small mouse, and ensuring that food sources are completely inaccessible to rodents. In a maritime environment where supplies are constantly being loaded and offloaded in various international ports, maintaining a rodent-free environment requires constant inspection. Public guidance for those who may have been exposed emphasises the importance of monitoring for early symptoms, which often mimic the flu. These include fever, severe muscle aches, particularly in the large muscle groups like the thighs, hips and back, and fatigue. If the disease progresses to the respiratory phase, symptoms include a sudden onset of shortness of breath and coughing as the lungs fill with fluid. Health officials stress that there is no specific cure, vaccine, or even a targeted antiviral treatment for hantavirus infection. Instead, clinical management relies on early recognition and intensive supportive care, often involving intubation and mechanical ventilation in an ICU setting. This lack of a silver bullet treatment makes the surveillance of ventilation systems even more critical. There are honest limits to our knowledge regarding how hantaviruses might adapt to shipboard environments. Most studies focus on terrestrial outbreaks, and the dynamics of aerosol concentration in a pressurized shipboard HVAC system are not fully documented. This uncertainty necessitates a conservative approach to safety. Scientists continue to monitor environmental factors, such as local weather patterns and rodent population surges in port cities, which may increase the likelihood of a vessel becoming infested. As the investigation into this specific cruise incident continues, the global health community is reminded that surveillance must be as mobile as the people it protects. The calm, methodical closing of this case will depend on the successful decontamination of the vessel and a transparent report from the investigating agencies. For now, the most effective tool remains awareness and the strict adherence to sanitary protocols that keep the boundary between human living spaces and the natural reservoirs of disease intact. By understanding the mechanisms of transmission and the realities of the virus, we can better navigate the risks of a globalized world. For more updates on global health reporting and investigative news, consider staying tuned to this channel. The core of the current investigation into the vessel's environmental safety centres on the technical assessment of its heating, ventilation and air conditioning, or HVAC, infrastructure. In a modern cruise liner, these systems are designed to regulate air quality, temperature, and humidity across thousands of individual cabins and large public spaces. However, according to the source material, the virus has managed to utilize these very conduits to seep through the ship's interior. For epidemiologists, this points to a specific and dangerous mechanical failure. When rodent reservoirs, the natural hosts of hantavirus, gain access to the ship's plenums or service crawl spaces, their waste materials, including urine and droppings, accumulate. As these materials dry, they become friable, meaning they easily break down into microscopic dust. When the ship's high-powered fans engage, this dust, which contains live viral particles, is drawn into the airflow and distributed throughout the ship. This process of mechanical aerosolization effectively transforms the life support systems of the vessel into a delivery network for pathogens, bypassing the typical environmental barriers that usually limit hantavirus spread to specific, localized nests or rural outbuildings. Laboratory and diagnostic protocols are currently the primary focus for health agencies, such as the Centers for Disease Control and Prevention and international maritime health regulators. Identifying hantavirus in a shipboard population presents significant logistical hurdles due to the virus's lengthy incubation period. Symptoms generally do not appear for 1 to 8 weeks after initial exposure. Because of this lag time, many passengers may have already disembarked and returned to their home countries before the first signs of illness manifest, complicating global surveillance and contact tracing efforts. Clinical laboratories utilize a multi-tiered testing approach to confirm suspected cases. The first line of defense is often the enzyme-linked immunosorbent assay, or ELISA, which screens for specific antibodies. Specifically, technicians look for IgM antibodies, which indicate a recent infection, and IgG antibodies, which suggest a slightly later stage of immune response. However, early in the infection, these antibodies may not yet be detectable, leading to potential false negatives. For a more definitive diagnosis, reference labs use reverse transcription polymerase chain reaction, or RT-PCR. This molecular test identifies the unique genetic sequence of the hantavirus RNA in blood or tissue samples, allowing scientists to confirm not only the presence of the virus, but also the specific strain involved. The contrast between sensational claims and verified medical information is a key element of the current reporting. While the source characterizes the vessel as a biotrap, public health officials emphasize that hantaviruses, with the notable exception of the Andes virus found in parts of South America, are not known to spread from person to person. Therefore, the risk is strictly environmental. If the ship's ventilation system is compromised, the trap is the localized concentration of aerosolized particles within the ship's sealed environment rather than the presence of other infected individuals. This distinction is critical for managing public alarm and determining quarantine procedures. On the logistics front, the decontamination of a large cruise ship is an immense undertaking. Decontamination crews must follow rigorous biosafety protocols, often wearing full-body protective suits and powered air-purifying respirators. The process involves the use of concentrated chlorine-based disinfectants, or professional-grade virucides, to neutralize the virus on every surface and within miles of intricate ductwork. Every filter must be replaced, and every possible rodent entry point, some as small as 6 mm, must be identified and sealed, as specialized labs continue to sequence the viral samples. The focus remains on the intersection of travel logistics and public safety. Shipping and port authorities must balance the need for a thorough biological investigation with the logistical reality of managing a massive vessel and its crew under quarantine. While the economic impact on the cruise line is substantial, the priority for international health agencies remains the accurate tracking of every individual who may have breathed the air within the compromised zones. The scientific consensus is clear. Until the source of the rodent infestation is located and the ventilation system is certified as fully decontaminated, the vessel remains a significant focal point for global health monitoring. This data-driven approach aims to provide a clear picture of the risks involved, moving beyond headlines to the methodical work of preventing further exposure and understanding how modern infrastructure can inadvertently facilitate the transmission of zoonotic diseases. The transition from emergency response to long-term prevention requires a comprehensive overhaul of maritime public health standards and a renewed focus on the One Health approach, which recognizes the interconnectedness of human, animal, and environmental health. For the cruise industry, the primary takeaway from this incident is the absolute necessity of rigorous integrated pest management, or IPM. This is not merely a matter of aesthetic cleanliness, but a critical biological safeguard. Practical prevention starts with exclusion, the physical sealing of every potential entry point for rodents. Because mice can fit through holes as small as 6 millimeters, or about 1/4 of an inch, inspectors must scrutinize every cable chase, pipe penetration, and storage locker. In the context of the reported biotrap on the vessel, this exclusion must extend to the HVAC plenums and intake systems. Furthermore, health officials emphasize that when rodent evidence is discovered, the method of cleaning is just as important as the cleaning itself. Standard household practices like sweeping or vacuuming are strictly prohibited in suspected hantavirus areas because these actions disturb the dried droppings and urine, forcing the viral particles into the air where they can be inhaled. Instead, the protocol dictates a wet disinfection method, soaking the area in a solution of 1 part bleach to 9 parts water for at least 5 minutes before carefully wiping it up with paper towels. Public guidance for travellers and the general public focuses on the early recognition of symptoms, which can be deceptive in their initial stages. The prodromal phase of hantavirus pulmonary syndrome typically begins with a high fever, deep muscle aches, particularly in the back, hips and thighs, and significant fatigue. Some patients may also experience abdominal pain, headaches, and chills. Because these symptoms mirror the common flu or even COVID-19, medical professionals urge anyone who has recently travelled on a vessel or visited a high-risk area to disclose their travel history immediately upon seeking care. Once the virus moves into the respiratory phase, the progression is rapid and life-threatening. The virus causes the capillaries in the lungs to leak, leading to pulmonary edema or a buildup of fluid in the air sacs. This causes the sensation of air hunger or severe shortness of breath. Since there is currently no specific antiviral drug, vaccine, or cure for hantavirus, the limit of medical knowledge remains a significant factor in patient outcomes. Treatment is entirely supportive, meaning clinicians can only manage the symptoms through oxygen therapy and mechanical ventilation, while the body attempts to fight off the infection. This lack of a targeted pharmaceutical intervention places the burden of safety squarely on environmental surveillance and early detection. Global surveillance systems, such as the Vessel Sanitation Program managed by the Centers for Disease Control and Prevention, are now under pressure to incorporate more specific hantavirus monitoring into their regular inspections. This includes checking the integrity of HEPA filters and ensuring that air handling units are not located near potential rodent nesting sites. However, an honest assessment of current knowledge reveals significant gaps. While we understand the basic mechanism of hantavirus transmission, the long-term stability of the virus within a pressurized, temperature-controlled ventilation system is not fully documented. It remains unknown how long the virus can remain viable in dust trapped within ductwork or how specific humidity levels on a ship might affect its potency. These uncertainties necessitate a precautionary principle in maritime engineering, where safety margins must be widened to account for the unpredictable nature of zoonotic spillover events ethically. This reporting highlights the tension between the global tourism economy and the fundamental right to biological safety. As cruise lines and travel operators move to restore public confidence, transparency becomes the most valuable currency. Withholding information about potential infestations or environmental breaches not only endangers lives, but also undermines the international health regulations designed to prevent the spread of disease across borders. The responsibility for safety is shared between the operators who maintain the ships, the agencies that inspect them, and the passengers who must remain informed. By sticking to verified protocols, such as the 110 bleach disinfection, the use of professional-grade PPE, and the sealing of structural gaps, the industry can mitigate the risk of another biotrap scenario. In a world where urban and wild environments are increasingly blurred, Vigilance is the only viable defense against the hidden threats carried by nature's smallest reservoirs. For more in-depth reporting on public health developments and global safety standards, please consider subscribing to our news service.